What is Azure Cosmos DB? Azure Cosmos DB is a globally distributed, multi-model database service designed for use in mission-critical systems. It provides turnkey global distribution, seamless horizontal scaling, and guarantees low latency, high availability, and strong consistency over a schema-agnostic data model. Global distribution. One of its prime features is global distribution. You can distribute your data across various Azure regions with just a few clicks or a single API call. Multi-model support. It supports a variety of NoSQL data models. Low latency. The service guarantees less than 10 milliseconds latencies for both reads and writes. High availability. Azure Cosmos DB provides SLAs with up to 99.999% availability, ensuring your data is always there when you need it. Capacity. You can choose between provisioned throughput or serverless options for capacity. Provisioned throughput guarantees performance, while serverless is more cost-effective for sporadic workloads. Certainly, let's discuss the pivotal concept of consistency levels in Azure Cosmos DB. Understanding consistency levels is crucial for developing applications that meet specific data guarantees. Consistency levels. Azure Cosmos DB offers 5 consistency levels, each with its own set of trade-offs between performance, availability, and consistency. The levels are: 1. Strong consistency. 2. Bounded staleness consistency. 3. Session consistency. 4. Consistent prefix consistency, and 5. Eventual consistency. Strong consistency. Description. Guarantees the highest level of consistency. A read always returns the most recent committed write. Use case. Financial systems where a strong consistency model is essential, such as stock trading applications. Bounded staleness. Description. Guarantees that reads may lag behind writes by a specific time or number of versions. Use case. Systems like weather data monitoring, where a slight lag is tolerable but a certain degree of freshness is desired. Session consistency. Description. Guarantees consistency within a single session, making it most predictable for an individual user. Use case. E-commerce websites where a user's shopping cart needs to stay consistent throughout a browsing session. Consistent prefix. Description. Guarantees that reads never see out of order writes. Use case. Activity feeds, where it's important to maintain the sequence of events but not necessarily the most up-to-date state. Eventual consistency. Description. No ordering guarantees are provided. Over time, replicas converge. Use case. Search engines or caching systems where high throughput and availability are essential, and eventual consistency is acceptable. Data models. Azure Cosmos DB provides multi-model support, making it possible to work with 1. Document-oriented, SQL API and MongoDB API. 2. Column family, Cassandra API. 3. Key value, Table API. 4. Graph, Gremlin API. Document-oriented, SQL API and MongoDB API. Description. This model is optimized for JSON data and supports a hierarchical, nested structure. Use case. E-commerce platforms can benefit from this model to store products, customer data, and order histories with intricate details. Column family, Cassandra API. Description. This model is optimized for queries over large volumes of extensively distributed data. Use case. Time series applications like IoT event storage or monitoring systems where data is collected in real time and queried later. Key value, Table API. Description. This model is designed for high-speed operations on large-scale data with a simple schema. Use case. Session storage or caching scenarios are best served by this model, as you frequently read and write based on a simple key. Graph, Gremlin API. Description. This model focuses on the relationships between data points, enabling traversal queries. Use case. Social networking applications or recommendation systems that need to analyze how entities are interrelated can benefit from the graph model. Purpose and usage. Azure Cosmos DB serves a variety of applications. 1. Real-time analytics. 2. IoT applications. 3. Mobile apps. 4. Web applications. 5. Gaming. 6. Content management systems. Availability. The service is designed to be always on with a financially backed SLA of up to 99.999% availability, both for reads and writes, with multi-homing capabilities. Scalability. With Azure Cosmos DB, scalability is built into the service. You can scale your storage and throughput capacity independently and globally. How to use. 1. Creation. Create an Azure Cosmos DB account from the Azure portal. 2. Configuration. Choose the model that fits your needs. 3. Global distribution. Set up your global distribution locations. 4. Data ingestion. Add your data using Azure SDKs or directly through the Azure portal. 5. Querying. You can use the SQL API or other compatible APIs to query your data. Summary. What? Azure Cosmos DB is a globally distributed, multi-model database service. It's particularly useful when you need low latency, high availability service and the ability to scale effortlessly. Types. Supports document-oriented, column family, key value, and graph databases. Features. Offers global distribution, multi-model support, low latency, and high availability. Consistency levels. Azure Cosmos DB offers strong, bounded staleness, session, consistent prefix, and eventual consistency levels. Strong, suitable for financial systems requiring the highest level of consistency. Bounded staleness, ideal for applications where some data lag is tolerable, such as weather systems. Session, best for scenarios like e-commerce where data must be consistent within a single user session. Consistent prefix, useful for activity feeds where the sequence is important. Eventual, apt for high throughput systems like search engines where eventual consistency is acceptable. Document-oriented, SQL API and MongoDB API, best for hierarchical, nested JSON data like e-commerce platforms. Column family, Cassandra API, suitable for time series data, useful in IoT event storage. Key value, table API, ideal for high-speed, large-scale operations with simple schema such as session storage. Graph, Gremlin API, tailored for applications that focus on the relationships between data points, like social networks. Capacity, options between provision throughput and serverless. Purpose, suited for a broad range of applications, including real-time analytics, IoT, and mobile apps. Availability, up to 99.999% SLA-backed availability. Scalability, designed to scale automatically and globally. Usage, create an account, configure it, set your global distribution locations, ingest data, and query as needed. Thanks for watching.